So I've been thinking to myself, what could be the best way to teach a new programming language or even the concepts of this language to others? And the answer is pretty simple. It's just to build cool stuff. And that's why I will build together with you a CLI tool in Rust and Tokio to basically get the most upvoted issues from a GitHub repository. But just be sure that you know the basics of Rust, because obviously I won't explain every single detail and every single character. It's important to note that this kind of mini-series consists of two parts, where the first part consists of basic functionalities and the foundation of the CLI using simple requests to get data from the GitHub API and to load this data and to really understand it and use it in Rust. And then the second part consists of the parallelization of the CLI tool. And clearly we can optimize a lot of things if we want to go further than that. Alright, so let's get into the fun stuff here. So what we have here is a really simple GitHub repository, right? And what we want is to kind of generate this list automatically. Now there are a lot of more examples where this list is applicable. So for instance, we also have the official Z GitHub repository where we basically do have the top ranking issues all time, right? And there is a lot of upvotes going on here in Z. And we want to kind of re-implement this functionality we actually see here, right? Not really with the categories, but with the issues and the upvotes, which are marked, by the way, with this thumbs up or +1 in GitHub. I mean, surely we can use another easier programming language than Rust, right? We could use Python or Golang, for instance. However, I think when you want to learn something, you should actually build something. And that's what we are going to try here. So the goal of this video is not to have a pixel perfect CLI, right? The goal of this video is just to showcase how you can approach different Rust problems or different business goals basically, or business problems with the help of the programming language Rust. Alright, so let's get started with our main function here, right? So in this program, we basically don't have anything. We don't have any dependencies and we only have a main function. But this will change in a minute here. Now, the first thing we are going to do is kind of lay out what we actually want to do in the main function, right? So we want to kind of get the issues, and then for each specific issues, we want to retrieve the reactions or the amount of upvotes for the specific issue, right? So that basically means that, for instance, we say let issues and then we call a function called getIssues, right? Then we retrieve all the issues from a defined or predefined repository. And then we want to iterate over all of the issues. And in this for loop, we want to get the reactions, right? So let's say reactions is equal to getIssue reactions. And then we say issue here. So I mean, something like in this direction, right? And from there on, we can now build the two functions. So let's just start with the getIssues function here. So what we do is just create a new function called getIssues. And this function basically returns a list, right? Because we want to iterate over our retrieved issues. And obviously we want to retrieve all the issues and not a single issue. So let's just say vec, because we want to have a list of some things, right? In this case, a list of issues. And then we say issue. So issue doesn't exist yet, and that's why we are going to create a new struct called issue. All right, now things are getting pretty interesting because this struct issue should represent the data we actually retrieve from the GitHub API. So what we could do is just Google GitHub API. There is a public and free API available by GitHub. And if we just search for issues, for instance, in the GitHub docs up here, for instance, issues, then we will get a huge documentation about the possible endpoints we can request to get some sort of issues, right? And what we are interested in are the repository issues here. So what we can see is basically the endpoint we need to call, right? Obviously, this is not enough. We still need to kind of say api.github.com. And then we need to define this endpoint. Then we also, it seems like some sort of token. And then in the end, the response is this here, right? So we have a list of issues. So obviously I'm not going to copy all of the data points here, right? Of all of the fields. I'm going to specifically only focus on the fields we actually need, right? And it's important to note here that it actually says in the documentation that GitHub's REST API considers every pull request an issue, but not every issue is a pull request. And here the important thing is you can identify pull requests by the pull request key. So what we are obviously interested in is not the most upvoted pull request, but it is more like the upvoted issues, right? So we are going to make use of the pull request key, which is defined here. And this can obviously be kind of empty or non-existent. And then what also is important is that we do not retrieve the ID, because I think this is the ID of the issue in the list. Yes, it actually stated here, right? It is actually an issue ID, and so it's not the issue in the list, it's actually an issue ID, but we are more interested in the number. So if we go back to my repository here, the number is this 380, right? It is not the ID, it is the number. Now, next to the issue number, and if it is a pull request or not, we can also retrieve the title, right? I mean, this could be pretty relevant if we want to display the title. For instance, here the title is this, right? Set front matter when changing icon. This would be the title, and we can basically retrieve this from the API here. So let's get started with this API. So as I said earlier, we do want to retrieve the number, right? And we also do want to retrieve the title. And the title is a plain string. And then what also is important is we need the pull request, right? Which is an option of the struct pull request. And we're going to declare a empty struct here, pull request, right? And this is now our sort of structure here for getting the data from the GitHub API. Now, as you can see here in the API itself, some endpoints require some authorization, right? So we need to define these 3 headers here to retrieve the data from the GitHub API. So what we need to do is to create a PAT token on GitHub itself to basically retrieve data from the GitHub API. Now then, best practice is here to define this token inside of an env file, right? So we can make use of the .env package or the .env crate in Rust. So we are just going to say cargo add, and then we are saying .env. And this is now our first crate we are going to use. Then after that, in the main function, we are just going to say .env, and then we are going to say OK to basically discard the error or ignore the error and only basically load the env variables if this file really exists, right? And then we have an env file, and in this env file there is the token, right? So I'm obviously not going to show my personal token here, but we can now work with that. Now inside the getIssues function, we can now make use of this token inside of our env file. Now what we'll do is we're going to define a new variable called token, and then we get this variable by using the standard env var. And in here we are going to call the key GitHub pat, which is basically the key of the key value pair of our env file. And then we expect this, right? So whenever there is not this token, we are just going to throw an error here, and we are going to say expected GitHub pat in env file. Now to basically create a request to the GitHub API, we can make use of another crate, and we are going to add request with a W. And then we are going to derive the feature or select the feature JSON because we want to retrieve and send JSON data. Right after that, we can create a new client of request basically, right? So request and then client and then new. So now we got a new client. And then we can call this endpoint by just saying client.get. Then we define the URL. In this case, we are going to kind of format things here because we obviously want to be as dynamic as possible with the token and the URL. So we're just going to say let URL format. And then in here, we are going to basically select the GitHub API string, right? And then we are going to insert the repository and the owner of this repository. So in this case, the owner is me. Obviously, the repository is pretty clear, I think, as well. And this is the API endpoint we've actually inspected before this definition of the URL here, right? So we got the owner here as a placeholder, the repository here as a placeholder. Then we get all the issues, but we also have a few query parameters. So obviously all the issues are paginated, right? So there can be thousands of issues. But for now, we only want to get the first page and the first 100 results. Right after that, we can pass in here the request URL. So let's quickly rename the URL to request URL. And then we can define the header, which will be authorization. So we say authorization, and this will come from the request crate as well. And for the value, we are going to set a bearer token. And then we are going to make use of the token, where the token is basically our token, right? So obviously we need to use format here as well. And that's basically it. Right? So we now kind of defined a header authorization with this format here. Now, obviously we need a lot more headers. So for instance, we need the user agent as well. And in this user agent, we can kind of define our user agent we want to identify this CLI as. So for now, let's just say Rust Web API. Let's keep it simple. Now, obviously, we can also define this in a env variable, and we are going to do this in the next episode of this mini series. And then we also need to define the accept header. And in here, we are going to kind of copy this accept here, this header. And we are just going to make use of it, right? So this is defined by the GitHub API. We don't need to worry about this. And then we are going to send this, and then we are going to await. Now, await does not work at the moment. The reason for that is because we need to declare this function as asynchronous. Now let's just return an empty vector here, just to get rid of all the errors, right? And what we actually get here in our main function is that issues is now a future, but we want to not iterate over the future itself, but we want to iterate over the vector, right? The retrieved data. And that's why we are going to await this as well and mark the main function as asynchronous as well. Now the thing is, Rust does not have a standard async runtime, and that's why we are going to make use of Tokio in this case. Now Tokio is an async runtime in Rust that is defined for asynchronous operations, and it is the most popular one available. So what we're going to do is cargo add Tokio, and then we're going to say -f full. And after that, we can make use of a macro and say Tokio main to define this main function, or to basically say that this is now a Tokio async runtime, right? And now we can run this main function without any problems. So getting back to our get issues function here. What we're going to do now is to get rid of our result here, right? So this is a result where we can kind of get a response, but also an error, right? So for instance, the error could be an internal server error, right? Possibly the API is not available for whatever reason. So what we could use is just the match keyword, right? And then in here we can say, okay, let's say res. And if it is okay, we just return res, right? And the default case would be just an empty vector. Now it is important to note that we also want to check if the status was successful, right? And is success means here in the HTTP status range within 200 to 299. So whenever we get a 404 response, which is not an error directly, it is just a response from the server, we just return an empty vector, right? So this additional if condition just makes sure if the response was successful. Okay, that's pretty cool. Now I forgot we need to return and then vec new. Right? And now the response is an actual response, right? So what actually happens here in this kind of else condition, if you want to say, on a default case, whenever the response was not successful, we just return an empty vector to the get issues function, right? And we kind of stop the operation of this function here. All right, now to actually retrieve the issues, we now need to make sure that we convert the response to an actually JSON response. Now to do that, we just say response.json.await, and then we also make use of expect. So we say something went wrong while passing. Now and then, like I said before, we want to kind of filter the pull requests out of this response, right? So we only want to focus on the issues. So what we then need to say is into iter, right? And then before actually continuing here, we obviously need to define the generic, right? How this kind of response should be transformed or deserialized to our struct in Rust. We are just going to define a vector of issues, right? And here's another problem. Now this vec issue does not have any serialization going on, right? So we need to now make sure that this is serializable and deserializable. Right, with that in mind, we can just say cargo add Saturday-f and then derive. And with that, we can now define our popular macros, serialize and deserialize. Now, obviously, the pull request struct here also needs to be serializable and deserializable. And now this also works, which is really great. So getting back to our JSON deserializing, we now want to filter over our kind of response or the list we actually retrieve from our response, right? And we say issue here. And then we want to filter out where the pull request is none, right? So we want to filter out all of the pull requests and only retrieve the issues of the repository. Now after that, we can just say collect. And this kind of works, right? We are now going to define vec and then underscore. So this is kind of a magic way to automatically identify the type of the vector here, which in the end is issue in this case. And now we can save this in a variable called issues. And that's basically it, right? Now we have all the issues for this corresponding request here. Right, so let's, for demonstration purposes, return issues just to demonstrate the functionality if that actually works. And then let's just print for now all of the issues. So we're going to comment this out. Now, obviously issues is not printable because we need the debug macro here as well. And now we can run cargo run. And with that, we now have all the possible issues or all of the first 100 issues for our repository, right? So for instance, we can see the number 539, which has the title bug and then icon doesn't render and edit preview mode. So if I copy this number here and then go to the repository and just paste in this number, we actually see the issue. So this actually works, which is pretty good, I think. Right now, the only problem is that we only get the first 100 issues, right? So, but obviously all the popular repositories do have more than 100 issues, right? So what we can do is to make use of some kind of recursive functionality to call this function again whenever we hit a pagination, right? Or whenever this is not the last page of our kind of list of requests to the GitHub API. So what we can do is make use of the headers in the response itself to retrieve if a next page exists, right? And what we can do here before actually converting the response to a JSON format, because the JSON format does take ownership, we need to make sure that we do this before actually transforming this to JSON in this case, right? What we can do is say let new URL, and then we are going to create a new function called construct new URL. And then we say response.headers. Now this function here, like I said before, just retrieves the headers of the response. And I'm going to show you what actually this headers prints in the construct new URL function. So let's quickly create this function. So we're going to say construct new URL, and then this returns a option of type string, right? So obviously there can be a new URL, which is the next page, and there can be no URL, so no new page or no next page, right? And in here in the construct new URL, we need the headers, which is of type header map, right? So we don't take ownership of the headers itself. We are just going to make use of it and just want to read things here. All right, and let's just quickly print the headers. and then we return none for now. So what happens if we run cargo run is basically we get all the issues, but we also get the headers. But the header we are looking for is the link header, and I've just Googled using pagination in the REST API of the GitHub API, right? And what we see here is basically you can use the link header from the response to request additional pages of data. If an endpoint supports the per page query parameter, you can control how many results are returned on a page, right? And because we make use of the per page parameter here, of the per page query parameter, we can make use of the link header. So what we can do is headers.get and then link, right? What should now happen if we run cargo run is we should get a link value, right? And for me, the funny thing is that it is none because I do not have more than 100 issues. But let's quickly change this. Let's say I have maybe 50 issues per page. Then I should get a new link, right? I should get a next page. And we actually get some link here, right? Which is pretty good. We say, or we get the URL page 2. So we can now work with that. So let's just keep the 50 here. We can change it in the future. And now we are going to work with the link here. So what we're going to say is headers get link. Then we say and then. Now this and then is only executed if the link really exists in the headers. So then we say link header. And then we are going to execute some functionality. Now in here we are going to say link header.toString.ok. We are going to ignore the error, right? We are only curious if this link header is actually a string. Then we say and then, so only execute if it was successful. Then we get the link value, and then we check if the link value contains this sort of magic here. So we are going to escape the quotes, and then we're going to say next. So this kind of means if there is a next page, we are going to make use of it, right? We care about this and we want to retrieve the data of the next page. And then we say then, and then in this function again, we are going to execute more logic. Because now we want to split or get the new URL, right? Because as we actually saw here, this string, this sum string, right, consists of the URL and the next kind of identifier, right? And we want to split this by semicolon and then only get this first part here. So let's quickly do this by just saying link value dot split by semicolon. And then we collect it and we say here vec and then as kind of strings. And then we say get 0, right? Because we want the first element of this splitted vector or list in this case. And then we say expect. And then we say toString to finally convert the value to a string. So in the expect, we also want to make sure that we kind of print the error if there is any error, right? So could not find new URL with page. I think this should be relatively clear. All we do is basically convert this first thing here, this first element in the list to a string, or in this case, to an uppercase string, right? So there is a fundamental difference between this and string and uppercase string, but I'm going to make an extra video of that specifically because it would be too much to explain here. So we now have a new function we can make use of. So let's get back to our get issues and let's have a simple recursion, right? So after fetching the issues, we're going to make use of the new URL. So what we can say is if let some new URL, right? So if the new URL actually exists, we are going to say the following, more issues, and then we are going to not call the native function, but a wrapper function. And then this is also asynchronous, so we say await. Now in here we are going to pass in the new URL, right, which we actually wrap in a sum. So this will actually be a option here. And then we concatenate our existing issues with the other issues, so that in the end we do have a list of all the issues of the repository. So we just say issues.iter.chain and then more issues.collect. Now obviously this does not work because the type is not known, so let's quickly create the getIssues wrapper function. So let's say getIssues wrapper. And then in here, we need the option string, right? So the URL we actually want to call, or the next URL of the page we want to call. And then this returns a box future. Now, box future is a combination of a box pin or a pinned box and a future, right? So this could be pretty complex if you're new to Rust, but I will also make a new video about the box concept in Rust specifically. But overall, the box is just some heap allocated memory. And this box future we are going to import in a minute here is just a type alias for a pinned box and a future. And a pinned box basically just means that it makes sure that the data is not moved in the memory somehow, right? And this is especially important for recursive calls. Now we are also going to create this function because we cannot directly call getIssues because of all sorts of ownership and Rust related issues. So we are just going to create a function here, which is a wrapper to make our lives easier. So let's import the box future by just adding a crate called futures, right? And then this box future, which we are going to import, needs two generic parameters. The first one is the lifetime. I'm also going to make a video about that. But static means that this specific struct or thing in the memory can live in the duration of the entire program, right? Which is fine for now. So let's say static, and then we are going to say vec and issue here. And then in the wrapper function, we are going to create a new pin box. And in this pin box, we are kind of calling the getIssues function again with the new URL. And obviously this getIssues function has to be transformed to accept this new URL. So because this is an option, we just say URL option string. Now then we have the getIssues wrapper function, but then obviously we need to make also use of the URL in our logic here, right? So we say URL.unwrap or, so we just have here the request URL, which should be the URL, but if this is not defined, right? If this is none, we just use the default value, which is this here. I think that's it. Let's go to the main function and make use of the URL, which we are going to say none for now. Obviously, this can be improved here to just make use of the URL directly in the getIssues function. I mean, of the parameter in this case. And then we are also fixing a smaller issue, which we are not going to make use of the iter function, but the into iter function, which just creates a consuming iterator, which is necessary for the chain function in the end. Right, and I think that was it, right? So now we have a list of issues. So let's quickly run the program here. And what we should get is a lot more issues, right? So let's quickly, just for testing purposes, print the length of our issues list here. And what we get, what I also forgot is we need to trim the first character and the last character, right? Because at the moment, the second page is not a valid URL. So we are going to fix this specific issue right now. So let's just remove the print line here. This was just for some debugging purposes. And then let's go to our construct new URL. And what we're going to say now is trim start matches. And we're going to trim, in this case, this character here. So the less than character, right? So let's make this more beautiful. And we are also going to make use of the trim and matches, where we are going to trim the last character. Now I think there can be a more beautiful way than like splitting and trimming the beginning and the end, but I think this is a for now solution. So let's just keep it as it is here. So if we now run the program, we now get the full list of issues, which is 94 in this case. All right, so after all of these minutes, we now have all of the issues we actually want to process and get the reactions from. So what we can do in the end is quickly get rid of this and then print again the issues.length here. So let's just say amount of issues. And then we are going to iterate over our issues And then we are also adding some print line information here. So for instance, issue, and then we say issue.number, right? Or issue.title. And then we want to define the reactions. So let's just print all of the reactions we have for a specific issue. So we say only reactions here. All right, that's pretty cool. I think get issue reactions is also asynchronous. So let's say await here as well. And then let's just create the get issue reactions function, which is asynchronous. And then we want a issue ID, right? And this is of type usize. The reason is pretty simple, because we have a separate section here in the GitHub API, which is only for the reactions. Right, so here first we see an about reactions section where we kind of get the content and then the emoji, right? So for now, we just want to say that the +1 is the upvote emoji. So let's just search here for repository or issue, because we want to get the reaction of a specific issue, right? And we have like listing, deleting an issue, comment reaction. And here it is, list reactions for an issue. And we want to call this endpoint. And what we need is just the issue number, right? And that's why we also want to retrieve the issue number from the original issues API endpoint. So with that in mind, we can now make use of this endpoint here in the same way we've actually used or have done with the issues endpoint. So in the end, this is some sort of list which returns a issue reaction. So clearly we need to create this issue reaction, right? So let's say struct issue reaction. Now obviously we also need the, let's say, debug, serialize and deserialize macros here. And in the issue reaction struct, we are now make use of the content, right? Which could be a heart, which also could be a +1. And then we also maybe want to get the username. So we are also going to make use of this user object here, which is again another struct. So let's say content, which is a string, and then we say user, which is the user struct. So we define the user struct here, also make use of the macros here, and then we want login, which is basically the username or the login name of this GitHub user. Okay, that's pretty cool. So let's get back to our function, our get issue reactions function. And now we are going to make use of the same functionality, or like some repeating functionality we've done in our get issues function. So I'm going to skip the writing part here. Okay, and there we go, we have it now. Now I'm going to quickly fix the error here, and then I'm going to quickly reiterate over this functionality. So in our get issue reactions function, we are going to say issue dot, and then we need the number, which is the issue number in this case, right? So not the issue, not the plain issue struct, but instead use the issue number. And obviously this function does not exist because we've named it get issues reactions, but we need the get issue reactions here. And there we go, we now have it. And what we got now in the logic of this function is basically we get the request URL by formatting these things, right? So we define the endpoint here with the reactions, and then we define the owner and repository and the issue ID. So I think this is really straightforward. What we also can do, but it's not necessary, is just to define the header, right, with the authorization. So I think the authorization header is also not necessary in here, but I think it's overall good practice to just define these three headers. So let's quickly define these three headers in here as well, right? And then we also need the token. So for now, we just copy this code. Obviously, this will be more beautiful in the next episode. And then we paste the token in here. So this is bad practice, just copying code. Obviously, don't do this. You can refactor this code if you want to, but I will do this in the next episode. And what we do now is send a request to the API and then transform the response to a valid JSON format using our vector of the issue reaction. So now we have a list of reactions, right? Because in the end, we can have multiple reactions on a specific issue. And then we just resolve or return the resolved response, which is a list of issue reactions. So that was a lot of code and a lot of explanations, but let's see what we actually got here. And what we do get is a lot of issues. So let's pause here because I don't want to print all the reactions and issues. I just want to demonstrate what we got here. So what we got is the issue title. So for instance, add toggle for disabling emojis. And in here we have a few reactions, right? We have 2 reactions which are both +1s, right? From 2 different users. So let's quickly verify that. So we just copy the title here. And what we can do is just search for this issue, right? And this is the issue. And what we have is basically or are 2 thumbs up emojis. So this is now working, right? It is working end to end, and we can now make use of the issues and the reactions. Now, obviously this is kind of slow at the moment because we don't pass them in parallel, right? And this is where the next episode will start, where we are going to make the code more beautiful and we are going to apply parallelism to this code here with Tokio in this case. I think there was a lot of code, a lot of explanations, and also a really long episode. But one of the most fundamental things in Rust is reference counting, right? Using RC or arc, for instance. And lucky you, I've made a video about that as well, which is much shorter than this one. Anyway, thank you so much for watching, have a lovely day, and bye bye.